So now we're going to talk about trig functions and the unit circle. And we'll start with their definition. So let's get it good enough. I keep doing that because I'm thinking about doing that, but this doesn't come out the circle very often. It gives me lots of ovals. Alright, good enough. Alright, got the pen back. X-axis, y-axis, angle, theta. Okay, unit circle. So unit. Now, you've worked probably with units in some science classes, but what does unit itself mean? Really means one. And unit circle, so when we talk about what property of the circle is 1, this is the radius. So obviously we're talking about a circle, pretty much the only measurement that's really important is the radius. So radius is 1. So if I label, there we go, that is a 1. Now I want to think about the point out here. Obviously it has an x-coordinate and a y-coordinate. And how do the x and y coordinate relate to theta? So we'll zoom in a little bit on this circle. So when theta is 0, you could probably tell me right away x and y. X is 1, y is 0. So y is definitely 0, so you're not going up and down at all. X is a 1 because the radius equals 1. So there are going to be some very easy points on the unit circle that we're going to look at, and there'll be some difficult points on the unit circle that we'll look at as well. So what are our trig functions? There are 6 trig functions. Their inputs are angles, and outputs our sides. So basically every trig function inputs or eats an angle and outputs or spits out a side. Or, well, you'll see ratios of sides. So it's a good way to think about trig functions. Their inputs are angles, their outputs are some sides. So there are 6 trig functions. We'll start with cosine first. So they eat angles. Now if you remember before, back in the day, functions, they pretty much only had one name. They were pretty much always called f, and their input was almost always x. So this is function name. Function name. And this is input name. So if we take that over to here, our function name is cos, and the input, or the input name is theta. You're going to find out very quickly that we're going to get lazy and not very frequently write the parentheses around theta. So you're going to very frequently see it just written as cos theta. Alright, so we can see our theta up here. Here's the theta. Cosine is the x-coordinate. This is the definition. So any angle theta you can think of, whether it's small, close to 0, or bigger, somewhere way over here, wherever this angle is, it's going to hit the unit circle, and it's going to have an x and a y coordinate, and if cosine is the function, the output is going to be the x coordinate right here. Now obviously most of these x coordinates are going to be very difficult to figure out what they are, but a few of them will be relatively easy, and we're pretty much only going to use those the entire quarter. So we'll get into those a little bit later. So this is our definition for cosine. Sine of theta, which I'm almost always going to write as just sine theta. This is the y. So the y coordinate up here, whatever that y coordinate is of the point, if your angle is somewhere down over here, the y coordinate, you could also write it over here on the y-axis. But that y value, however far down you have to go, that is the value, that's the output of sine of theta. So that's cosine sine. Next up, tangent of theta, and of course, I'm going to write that as tan theta. And tan theta is a little bit more tricky. It's y over x. So you're going to see the rest of the trig functions are all fractions as well. But the tangent of theta is the side y divided by the side x. So anytime you're going to, I don't know what this is. There we go. Anytime you're going to divide, you want to make sure when x is not 0, or make sure that x is not going to be 0. So when is x going to be 0? Just look in here. X is 0 right there and right there. So we're going to see that those are bad angles for the theta function. So just like any fraction, if you're divided by a variable, this can be defined when that variable on the bottom is not 0. So the other three functions are called the reciprocal functions. So reciprocal functions, we'll start at reciprocal of cosine, sec theta. Of course, we're just going to write sec theta. This is the reciprocal of x. Cosecant of theta. Cosecant theta, this is the reciprocal of y. And then cotangent of theta, we're just going to write as cot theta is going to be x over y. And of course, you'll be careful, all three of these when x not 0, defined when y not 0, all right, so those are the 6 trig functions. The standard, the first 3 I would just call those the regular trig functions or the standard trig functions. The second 3 I would call the reciprocal functions. So these are the definitions right here, and we're going to do some examples with these, just using the definition. And we're very frequently going to call this point, we'll use the letter P for point. This problem you're not going to see many more of these types of this problem, but it's a good warm-up. And theta correspond So theta is going to be the angle that passes through this point. And find the 6 trig functions of theta. All right, so this point, I do have an x and y coordinate. That's good. So let's go ahead and plot it first. There we go. Ooh. That'll work. All right. -1/2, that's the x-coordinate. We're going to go -1/2. So obviously, unit circle, that's -1. So I'm going to go exactly half that far. -1/2. And trying to pick accurately as I can. That's the point of the unit circle that we're dealing with. That's P. So theta, now it turns out it doesn't matter which way theta is measured, if it's positive or negative. So I'll just draw it as if it was positive. So I got negative 1/2. Oh, I messed that up. What did I do wrong? So my spidey sense kicked in because what I was about to write was this, and then I looked up here and noticed that it should be positive. All right, so that's a good example of what I call the math spidey sense, when you write something down and then something else doesn't make sense on your paper or in your mind. So how do we rectify this? Well, I got the x-coordinate right. The y-coordinate should be positive. So bad angle, not the point, not down there. I should have gone up. I arbitrarily went down. I don't know why. Should have gone up to the positive square root 3/2. There we go. Now our angle is in the right spot. Now, I did not ask for what is theta. So if I asked that question, it could be measured in radians or degrees, but I didn't ask that question. I asked for the 6 trig functions of theta. So what is cosine of theta? Well, definition is pretty much all we know. Cosine theta is the x-coordinate on the unit circle. So what is our x-coordinate? Right here, negative 1/2. It's our x value. So next up, sine. Sine is the y value, square root 3/2. Tan is y over x. And I don't know why I'm being lazy and not writing these. I strongly recommend that you write the definition down first and then write the value. Because every time you write cos theta equals x, sine theta equals y, you will remember it that much more. So I tried a shortcut right there, which I don't recommend you doing, because every time you write it out, it just gets ingrained in your memory a little bit more. So tangent theta y over x, looking over here, y, square root 3/2 divided by negative 1/2. Here we have multi-story fraction. We have to deal with this immediately. Whenever you have a multi-story fraction, the first thing you have to do is take steps so you don't have one. So what we're going to do is we're going to multiply by the reciprocal, and I'll keep going downwards here and I'll comment on the right side. So reciprocal of 1/2 is negative 2/1, and multiply that out. 2 cancels the 2, except there is still negative. So we can just write this as negative square root 3. So when you have a multi-story fraction, you multiply by the reciprocal of the denominator. So that is cosine and tangent. Now we're going to do the 3 reciprocals. Sec theta. Now if you know cosine, sine, and tangent, you don't have to do much to get the other 3 reciprocals. Cosecant 1/y, just looking up sine y, this is 2 over square root 3. And last up, cotangent's the reciprocal, x over y. I could copy this down, except flip the numerator and denominator, or why don't we just use this guy right here? So there's our 6 values. Now some of you might be rationalizers. And let me show you why rationalizing would not be good for most of the things that we're going to be doing. If you're a rationalizer, I'm done right here. I've already got the value. If you want to rationalize, you're going to have to multiply by square root of 3 over square root of 3, do some more steps. But not only that, if you're a rationalizer, think about going through cotangent and rationalizing. It's not a hard process to do. Cotangent theta, no problem. But what if you knew cotangent theta and you didn't know anything else, and that's all you knew, and I asked for tangent theta? All right, well, it's a reciprocal of what's written down. Except what's the problem here? Well, we have a rational in the denominator, so I still have more work to do. Square root 3 times square root 3 is regular 3. So now 3's cancel, and we have negative square root 3. And yes, that is what we got for tangent originally, but if you keep rationalizing and rationalizing everything, sometimes you'll have to basically unrationalize. So you're just basically going to create more work for yourself that I recommend that you don't do. I'll give you enough work that you shouldn't go and try to make extra work. So our next example, I'm going to give you information about theta, and then we're going to find the trig functions. Now, you don't usually have to find the second three, the reciprocal trig functions. If you find the first three, the last reciprocal trig functions are very easy. So I'm just going to find the three trig functions of theta. 3 pi over 2. How many rotations is that? Let's start with what we know. Two pi is 1 rotation counterclockwise. All right. Let's rewrite it with halves. So the only number you're allowed to multiply by and not change anything is 1, and I did that right here. All I'm doing is getting into a common denominator. So 1 rotation, oh geez, that's the worst circle I've ever drawn. All right, let's just cheat. Now my axes are bad. All right, and if we start labeling this, first thing I hit is pi over 2. We knew that was a quarter rotation from earlier. We hit pi over here. 3 pi over 2. I'm going to be a little silly and write 4 pi over 2, of course. That's 2 pi, obviously. And we could be a little silly with 1 and use 2 pi over 2. So why am I doing all these over 2's? Well, the reason fractions suck is because you're not using common denominators. So I'm going to erase everything that's not over 2, any denominator that's not common. Now if we look here, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. It should be pretty obvious how we're getting around this circle. We're just going pi over 2, pi over 2, pi over 2, pi over 2. You just keep adding pi over 2. And now, theta is 3 pi over 2. So the angle we're measuring is right here, 3 pi over 2. I know exactly where that's at on the unit circle because I carefully got common denominator so that I can understand exactly where 3 pi over 2 is. And what are we doing here? Find the 3 trig functions of theta. So cosine is x, which is, so what is our x coordinate here? Let's write down the xy coordinates. How much x do we have? We're not using any. And how much y do we have? -1. So cos is 0, sine of this theta is -1. Oops, don't be lazy, is y, which is -1. And tangent y over x, you see y and x right here, -1 over, uh-oh,